Today, I will share to you how to solve problems involving RC circuits and electrical crankshafts. If I at time t equals to 0 negative equals 2 amperes, find work at the capacitor at time t equals to 0 negative, work at the capacitor at time t equals to 0 positive, and current of the capacitor at time t equals to 0 positive. For given figure, our source 20 volts, our resistor 6 ohms and 4 ohms, our capacitor 1/20 farad, and the current at the resistor 6 ohms I, and the current at the capacitor IC. At time t equals to 0 negative, our current equals 2 amperes. If at time t equals to 0 negative and I equals 2 amperes, then this circuit is at steady state. It is at steady state because the formula for current equals I equals V over R, which is I, our voltage source is 20 volts, 20, over the series combination of 6 and 4, we add the 6 and 4 to get the total resistance, equals 2 amperes. So, at time t equals to 0 negative, our circuit will be our voltage source 20 volts, our resistor 6 ohms, and 4 ohms resistance. And at time t equals to 0 negative, our capacitor will be open circuit. BC, we should get the KVL at loop 1. At loop 1, KVL at loop 1. 20 volts minus 6 times the current 2 ampere minus 4 times the current 2 ampere equals 0. Minus 12 minus 8 equals to 0. And 20 minus 20 equals to 0. BC is parallel with 4 ohms. We will get the equation in the 4 ohm resistance. And VC equals 4 times 2. And we will get the voltage at the capacitor will be 8 volts. And now we will now get the work for the capacitor, which is WC. Equals to the formula for work equals 1/2 times the value of the capacitor times the squared voltage. And now we will now substitute the values for capacitor and voltage. WC equals 1/2 times value of C equals 1/20 farad times the squared voltage equals 8 squared. And now the work on the capacitor equals to 1.6 joules. And work at the capacitor at 0 negative, time t equals to 0 negative, equals to 1.6 joules. For time t equals to 0 positive, our VC at time t equals to 0 positive equals to VC at 0 negative. So, our VC at time t equals to 0 negative equals 8 volts. Our work at the capacitor at time t equals to 0 positive equals 1/2 times the value of the capacitor 1/20 farad times the squared voltage 8 squared. Our work at the capacitor at time t equals to 0 positive now will be equivalent to 1.6 joules. Time t equals to 0 positive, our circuit will become like this. Our voltage of the capacitor and the current at the voltage of the capacitor, IC. Our 4 ohm resistor and the current at the 4 ohm resistor, represented by IR. Able to get the value of the current at the capacitor, we will get the KVL at loop 2. KVL at loop 2. VC. We get VC a while ago. VC equals 8 volts. Now, 8 minus 4 times the current IR. And we got to 0. At the value of IR, we transfer the 4 times IR to the right side of the equation. It will become 8 equals 4 times IR. To get the value of IR, we divide both equations by 4. 4 will cancel and IR will remain. And the value for IR now is 2 ampere. We can now determine that IC equals to the negative of IR because they are in opposite direction. Now, IC equals to negative IR. Now, we get the value of IR a while ago. IR equals 2 amperes. It is said that IC equals the negative value of IR. Now, we will put the negative sign. IC now equals to negative 2 amperes. Now, we will get the value of the IC, current at the capacitor at time t equals to 0 positive, will become negative 2 amperes. Put our answer in our answer box. That IC at time t equals to 0 positive equals negative 2 amperes. Now, we now answer the problem, which is the value of work at the capacitor at time t equals to 0 negative equals 1.6 joules. And that work at the capacitor at time t equals to 0 positive equals 1.6 joules. And current at the capacitor at time t equals to 0 positive equals negative 2 amperes. Thank you for watching, guys, and please don't forget to like and share.